Here we have an application problem. It says a ski resort has several types of hotel rooms and cabins. The hotel rooms cost $89, or cost at most $89. That's important, at most. So they're $89 or less. Okay. And the cabins cost at least $109 per night. So we have that word at least, which means less than or equal to then, right? Write and graph a compound inequality that describes the amount a guest would pay per night at the result. So we're going to say the hotel costs at most $89. So I'm going to say let X be the cost of the room. So I'm going to say it costs at least $89, or at most $89. Geez, can't write. At most $89. So that means that most is going to be $89. So it's going to be X is greater than or equal to 89. At most. Try that again. That's wrong. At most means it's less than or equal to. So X is less than or equal to 89. At least is $109. So, and X costs $109 or more. So X is less than 89 and X is greater than 109. That doesn't make sense, does it? It can't be both at the same time. So I'm going to put the word and or in there. Because we're going to cost $89 if we spend a hotel room. We're going to spend $109 if we buy a cabin. So we're going to spend up to $89 or we're going to spend more than $109. And that's all you have to do. Oh, we're going to graph this compound inequality. So we're going to put this on our number line. And with the ors, we just put both numbers on the number line. So I have 89 here, and I have 109 over here. And I'm going to have less than or equal to 89. So I'm going to open our closed circle on 89. I'm going to shade to the left. Closed circle on 109. I'm going to shade to the right. And there you have it. With or, we just graph one or the other. And we just put them both in the same number line. And that's how we're going to approach example 3. First thing I'm going to do, I'm going to recopy this problem. I'm going to say negative 2m plus 7 is less than or equal to 13. So we're going to subtract 7 from both sides to get m by itself. So then we get negative 2m is less than or equal to 6. Divide both sides by negative 2. Remember, when we divide by negative, flip the inequality. I'm going to flip that right away so I don't forget. And we get m is greater than or equal to negative 3. Now I'm going to do my other inequality with the word or. It's just like we're doing two problems, but just we're graphing them both in the same number line. So 5m plus 12 is greater than 37. So I'm going to minus 12 from both sides. So 5m is greater than or equal to 25. Divide both sides by 5. M is greater than or equal to 5. So what I'm going to do, I'm going to put both these numbers on the number line. In other words, my number line has to contain the number negative 3, and it has to contain the number 5. So I'm going to go negative 2, negative 3. Whoops, try that again. I'm numbering backwards. Let's go negative 4, negative 3, negative 2, negative 1, 0. And then greater than or equal to negative 3. So I'm going to put a closed circle in negative 3. I'm going to shade to the right. or greater than or equal to 5. Well, actually, since they're both greater than, includes both of them. In fact, the first number, or the first inequality, includes them all. So your solution is just from -3, we're going to shade to the right. Because with the word or, it's one or the other. In this case, they just both overlap, so we include both of them.